In Part 5 of Lecture 6, we will discuss constructing an LR0 parse table. Let's put together the parse table. State 0 is a non-final state. All the dots are before the end of their respective item. That means the action is shift. If you follow the arrows, you will see that we will transition to states 4 and 5 on plus and minus respectively. We will transition on identifier and constant to states 6 and 7 respectively. There is no transition on dollar and the file marker because it doesn't appear immediately before the dot anywhere in state 0. State 1 only has two items, both non-final. On plus we transition to state 8, and on dollar we transition to state 12. State 2 only has one item, the final item, E derives T dot. This means that we will reduce by production 3. State 3 has only one item, the final item, T derives F dot. This means that we will reduce by production 6. State 4 has 3 non-final items. Therefore, the action is shift. There will be a different transition for each item. If the look-ahead is identifier, we will go to state 6. If the look-ahead is constant, we will go to state 7. If what we are transitioning on is F, we will go to state 9. State 5 has 3 non-final items. Therefore, the action is shift. There will be a different transition for each item. If the look-ahead is identifier, we will go to state 6. If the look-ahead is constant, we will go to state 7. If it is F, we will go to state 11. State 6 has one final item. Factor derives identifier. Therefore, the action is reduce by production 7. State 7 has one final item. Factor derives constant. Therefore, the action is reduced by production 8. State 8 has 6 non-final items. Therefore, the action is shift. We will transition on plus and minus to states 4 and 5 respectively. We will transition on identifier and constant to states 6 and 7 respectively. And on T and F, we will transition to states 10 and 3 respectively. State 9 has one final item. T derives plus F dot. Therefore, the action is reduced by production 4. State 10 has one final item. E derives E plus T dot. Therefore, the action is reduced by production 2. State 11 has one final item. T derives minus F dot. Therefore, the action is reduced by production 5. State 12 has the ultimate final item. S derives E dollar period. Therefore, the action is accept. What the slide shows here is the algorithm for an LR parser driver. What we're going to do is perform the action associated with the current state and token. If that action is shift, we shift the current token on the stack with the new state. If the action is reduced by production N, we will pop all the variables of the right sentential form together with their states. We will then push the non-terminal from the left side of the production together with goto of the state and the non-terminal. Accept means we will clean up and finish. Error means we will call whatever error handling procedure we have, and we will continue repeating this until the action for the current state and token is accept.